All right, these are the notes for the 9.3 for directional angles and dot products. To just simplify all of this, what this is saying on this page, what it comes down to is that this is the angle created for a vector, a unit vector, and it goes in the same direction as it would in our unit circle. So if that's true, then x is equal to the cosine of theta. Why is that true? Because this side is adjacent, this side is hypotenuse. Okay, just looking at what we know, and this side is opposite. So our x is the cosine of theta because it's adjacent over hypotenuse, and y is sine theta because it's opposite over hypotenuse. And remember, since this is a unit vector, that length right there is 1. All right, so that means that if xy is the same as cosine sine, this would be from the x's, all right, cosine sine theta, then our trig form of a unit vector would be cosine theta I plus sine theta j, all right? So looking at the next page, what I want you to remember from this, is that if I want to find the angle of theta, it's located in one of the 4 quadrants. It's either coming out here, or it's going this direction, or it's going this direction, or lastly, it could be down here, okay? And here's the thing, if you take tan inverse, so if this is what you have, tangent of theta is equal to y over x, or as you remember, sine over cosine, because that's what's here, sine and cosine, then you would do tan inverse of y over x to give you an angle. But to give you an angle theta, where that answer is going to be is always over here in one of these 2 quadrants. So you may have to do a little work if you want it to end up in the other places. So let's see what those values would be. Well, first of all, if it's positive, this would be theta, the reference angle. And then to get to this angle, you would have to do 180 minus theta, or your reference. To get to this angle, it would be getting all the way around to here is pi, or 180, and then this would be adding to that 180, or pi. So this one's 180 plus the reference angle, or theta. And then lastly, I'll do this one in red to match the red line. If we wanted to find this angle, well, to go all the way around would be 360. So it's just shy of there, and it's going to be 360 minus the reference angle, or theta. So it's different. It's not the 180, it's 360. And all angles should be positive angles. Okay? All right, so we have a unit vector. I have a calculator on hand with me. So when I do 2, -4, it's going to put it right here, which on your papers, unfortunately, falls off the paper. I should have made my size a little bit larger. Sorry, this is a little bit crooked, but if I could draw a straight line, it would have connected those two. And it doesn't matter because I'm going to do tan inverse of -4 over 2. Now, when I do tan inverse, second tan -4 divided by 2, it gives me -63.4 degrees. But that would mean from here to here. And if you remember at the bottom of the last page, we can have no negative answers. So what we want to do to find theta, to find this, is we're going to say 360 minus 63.4 degrees. And that's going to be 296. I'm doing it in a calculator because it's late. Don't want to make those mistakes. 296.6 degrees. Okay, there you go. Done with that one. Looking at the next one, we have -2, -3. 1, 2, 1, 2, 3. It's located here. I'm going to try. Hey, that one looks a little bit straighter than the last one. Here's my next vector. So I'm going to do tan inverse of -3 over -2. Now, I want to include both negatives, even though I know they both cancel out. Technically, these cancel. And I don't have to put it in as two negatives, but second tangent 3 over 2, I get 56.3. Now, where 56.3 degree ends up is somewhere up here. So 56.3 degrees does not represent this one down here, which is the one I want. All right. So what do we have to do? Well, this quadrant, third quadrant, is 180 minus 56.3. Oh, I just did minus and it should be plus. Let's talk about why it's plus. It's because you have this 180 and you're going to add that reference angle onto it. So 180 plus 56.3, 236.3. Okay. All right. So putting it all together, I'm going to let you look at this page. You can pause it, but notice what you do for the components. This is x2 minus x1, y2 minus y1. This is how this is figured out, and there's the answer. So initial is always the ones, and terminal is always the twos, like y2, y1. And x2, x1, those kind of things. You know, the x2, y2 is what that represents. All right, and then to write it, once you have this, to write it in the sum of unit vectors, it's just adding I and j, plus sign, drop the pointy little parentheses. All right, magnitude is the distance formula, and then the directional angle is inverse tangent, but you always have to go back and ask, what quadrant is this guy in? And he's +6, +3. He's in the first quadrant. All right. So let's find these real quick. Find the component form. So I would take -5 minus 3 and 2 minus 1. So that would give me -8, +1. Now, just so I know where that's located, -8, 1 is about here, coming from the origin, of course. I did increase the size of my origin so you could tell couldn't tell I missed it. Rewrite it as the sum of unit vectors. Well, that's -8i plus j. Find the magnitude. That would be the square root of 8 squared plus 1 squared, which is square root of 65. Which is fine by me, or second root 65, 8.1, 8.06 to be exact, but 8.1. This is an approximate, it is not exact. Find the directional angle of the vector, so that's going to be tan inverse of 1 over -8. I had to look and see. Pardon me, I started this too late. So second tan 1 divided by -8, -7.1. It's negative. So think about where we're located. Negative, this would be the reference angle is 7.1. This would be this side in this quadrant. So it's 180 minus 7.1. 180, 172.9, 172.9 degrees. Done. All right. You can pause and work on this one, or you can just do it with me. I'm going to take the twos minus the 1. These are the 2's. I'm going to put the 1's underneath it. It just kind of works out faster for me to do it that way. Oh, these are parentheses, not component forms of vectors. All right, so 2 minus a negative 5 is 7. 1 minus 4 is negative 5. And 7i minus 5j. All right. Yeah, I'm double checking. All right, find the magnitude. I need 7 squared plus 5 squared, which is 49 and 25. Plus 25 equals square root of 74. Square root 74. Root 74. 8.6. This is approximate, by the way. And the directional angle, tan inverse of negative 5 over 7. And that's negative 35.5, which is located down here. So this one is located positive, negative. Oh, it's located down there. So this is going to be 360 minus 35.5. 360, 324.5. 324.5. Let me make sure I copied it right. I did. Degrees. All right. Now, finding the dot product. Now, this is different. Finding a dot product, it is multiplying, but you don't end up with a vector. You end up with the two components multiplied together from here and then here and here. All right, those two components multiplied, then add them together. All right, so we're going to do an example so you can see that happen. I'm going to take A and B. A is 5, negative 2. B is 3, 4. And I stacked them like this on purpose because I'm going to grab these and I'm going to get 15, multiplying them together. I'm going to multiply these together and get 8. In fact, it's a negative 8. So I add these and that gives me 7 and I'm done. What if I do them backwards? Well, I have 3, 4 and I have 5, negative 2. When I multiply these, I'm going to get 15 plus a negative 8, which is still 7. All right, so doing AC, A is 5, negative 2. C is 7, negative 3. And when I multiply this side, I get 35. I multiply this side, I get 6. That's 41. There's my dot product. Okay, so dot products are actual numbers, not vectors. All right, C and D. C is 7, negative 3. And B is 3, 4. Multiplying the x components, I get 21, negative 12. Oh, and I almost made the mistake of using these. I don't need them. It's just going to be 24 minus 12, which is 21 minus 12. It looked like a 4. I did plus a negative. Let's fix what I did. 21 minus 12 is 9. Okay, sorry about that. Two vectors are orthogonal if their dot product is 0. None of these came out to 0, so none of these are orthogonal. We'll talk about orthogonal in about 3 seconds. All right, so if we want to find the angle between two vectors, here and here. And guys, this gets complicated. Think about when the vectors end up over here, down here, or over here. We've got to add or subtract to 180 or subtract from 360. So if you want to do this, what you're going to do is find u dot v first. And here's my two vectors. And I'm going to rewrite this just to have them right together. Here's v. All right, so grouping your x's, I get 12. My y's is 15. This is 27. The magnitude of u is the square root of 4 squared plus 3 squared. The magnitude of v is the square root of 3 squared plus 5 squared. All right, so that gives me, I need to do this twice. I got real happy with that. I'm trying to hurry. My apologies. 42 and 32, no, 4 squared and 3 squared. I'm crazy. 16 plus 9 is 25, so that comes out as 5. 3 squared is 9, 5 squared is 25. I'm at 34. Okay, so what you do now is you say cosine of theta is equal to 27 over 5 times the square root of 34. All right, well, that means that you do inverse cosine of both sides, cosine inverse, cosine inverse. So I have a tendency just to write this part right here. All right. So once I have that, I'm going to do second, I'm going to turn it back on, second cosine of 27 divided by parentheses 5 times the second root of 34. Let me make sure I've got it all. Double close parentheses. Whoops, that wasn't supposed to happen. Delete, arrow out, parenthesis. Delete, delete, arrow out, parenthesis, parenthesis. Sorry, it takes me a minute on this calculator. 22.2. There we go. And we're done. Now, the neat thing is with this, it doesn't matter where these two guys are located. If one's located here and one's located here, it's going to find that angle. If it was located over here, now there's two different angles it would find. If you're going for it, this angle, it'll find that. If you're going for this angle, it'll find that. So, and you don't have to figure out all the adding, subtracting stuff. All right, so now we have one in unit coordinate and quadrant 1 and 4. We're going to do it the same way. I like to have my numbers grouped together. It makes me work faster. And since you're having to listen to me, I'm going to work faster. So u dot v is going to be 12 times plus, my bad, negative 4, which is going to give me 8. And then the magnitude of u is equal to the square root of 2 squared plus 1 squared. I did not include the negatives because when I square them, it takes them out anyway. Square root of 5, the magnitude of v, is going to be 6 squared plus 4 squared, which is 36 plus 16, 52, square root 52, I believe. I'm double checking real quick. 36, 16, 40, 52. There we go. So I'm going to do cosine inverse of 8, which is the dot product, and then over these two. Now what I'm going to do is I'm going to write one big square root 5 times 52 because I can. It's a little easier to put in the calculator. Cosine inverse of 8 divided by second root 5 times 52, enter. 60.3. And I'm done. Theta equals 60. I love my 60. 60.3 degrees. All right, moving on. So to be parallel, okay, so if these lines go back, if these things happen to be parallel, they wouldn't run into each other. All right, so what's going to happen is that they can be parallel, they can be perpendicular, or we call it orthogonal, or they can be neither. Okay, any two lines you put together will be parallel, perpendicular, neither. So guess what? Any two vectors will be the same. And I added a couple of words on the one that I printed out for class. I said the angle between the two vectors, the two vectors are parallel if the angle between the two vectors is either 0 or 180. Not both, and not all the numbers in between. It's either between, okay, the angle between the two vectors is 0 or 180. They can go in the same or opposite directions. All right, the two vectors are orthogonal or perpendicular. Nice big word for vectors, orthogonal. If the angle is 90 degrees. Now, for it to come out to be 90 degrees, the dot product is equal to 0 because that means we're doing cosine inverse of 0. And that gives us 90 degrees. I want you to know that piece. All right, let's look at these examples. Again, I like grouping these together because it makes me speed up. A dot B is equal to these two multiplied, 6, plus these two multiplied, -6. Holy cow, it's 0. Okay, so what that means is that when I do cosine inverse of 0 divided by the two magnitudes, the two magnitudes are going to give me two numbers right here. It doesn't matter what they are. 0 divided by anything is still 0. So it's cosine inverse of 0, which is 90 degrees, which is orthogonal. I'm just writing ortho for short. All right. Okay, let's try another one. -3, 2. So on this one, my dot product, A dot B, is -9 plus -4, which is -13. That's not 0. I have to keep going. So the magnitude of A is the square root of 3 squared plus 2 squared. The magnitude of B is 3 squared plus 2 squared. Would you look at that? We got the same thing both times. Well, 3 squared is 9, 2 squared is 4, so this is 13, and this is 13. So that means, square root of 13, excuse me. That means I have cosine inverse of -13 over square root, I just realized what I did. Square root of -13 over square root of 13, square root of 13, which is just 13. Okay, so that gives me cosine inverse of -1, which if you remember the unit circle, that's 180 degrees. And we're done. Oh, so that means that we're parallel. Let's just go back and circle it. Parallel. Okay. Let's look at the next one. We have 9, -6. So the dot product first, A dot B, is 3 times 9 is 27, plus 2 times 6 is 12. That's 39. So then we find the magnitude of A, which is the square root of 3 squared plus 2 squared, which we've already figured out, is 13. The magnitude of B is the square root of 9 squared plus 6 squared, which that's 81 plus 36, which is 117, I believe. And so that means we have cosine inverse of 39 over. I'm going to make one big square root because I'm trying to save a little time. 13 times 117. I didn't write them as individual square roots, but they can be. Second cosine of 39 divided by second root 13 times 117, enter 0. This is not just 0, but it's 0 degrees, which means parallel, not orthogonal. Orthogonal is when the dot product comes out to 0. And if you see right here, dot product isn't 0, so it can't be orthogonal. So parallel for this one. Let's see what happens here. A dot B. Okay, I really want these written together because it speeds me up. All right, so this gives me 3 times 1 is -3 plus 5 times 15. I believe that's 75, which is 72. Definitely not 0. So I have to do the magnitude of A and the magnitude of B. So do the magnitude. We have 3 squared plus 15 squared. We have -1 squared. Let's make it +1 squared plus 5 squared. 3 squared. Let's just do it. 3 squared plus 15 squared equals 234. Square root of 234, and this is going to be 25 26, square root of 26. So cosine inverse of 72 over a big square root, 234 times 26. All right, second cosine, 72 divided by second root, 234 times 26, enter. Okay, I got 22.6 degrees. That's neither because it's not a 0, 90, or 180. There you go. And I'm done. The end.